scale drawing. A scale is the ratio of the length of a drawing to the corresponding length of the actual object. For example, a 10-kilometer road cannot be drawn on a piece of paper, and we thus scale it down and maybe say 1 centimeter on the paper to represent 2 kilometers on the ground, and thus we have a drawing on the paper of 5 centimeters. Types of scales, and there are 3 types of scales. The first one is a statement scale, and this is rather straightforward. Like the one we've just stated, 1 centimeter represents 2 kilometers, or sometimes we write 1 centimeter forward arrow 2 kilometers. The second type of a scale is a ratio scale, and now here you need to be more careful because the figures must be in the same unit, usually centimeters. For example, in the case we have above, you cannot write 1 to 2. No. You must convert the 2 kilometers into centimeters so that we have 1 to 200,000. The last type of scale is what is called a ratio scale. And just like the name says, we use fractions. The numerator must always be 1, and again the unit must be the same. So in the case above, we shall have 1 over 200,000. 1 over 200,000 is a fraction scale. Let's take an example. A triangular piece of land measures 400 meters by 600 meters by 200 meters. Using a scale of 1 to 10,000, represent this land on a piece of paper. So in my case, I'm going to represent that on my screen. Now from the scale given, 1 centimeter represents 10,000 centimeters, or simply 100 meters. Why? Because 100 centimeters is equivalent to 1 meter. So 400 meters is equivalent to 40,000 centimeters. So I'm going to represent my working like this. 1 centimeter represents 10,000 centimeters. 40,000 centimeters will be represented by what length? So I have 1 centimeter times 40,000 centimeters over 10,000 centimeters. Cancelling out, I get 4 centimeters. So this side shall be 4 centimeters on my screen. Now if you do the same with the rest, we shall have 6 centimeters and 2 centimeters, so that we can draw our triangle like this. Actually, you will need to construct it. Now when no scale is provided, you choose your own scale, and just ensure the scale you choose will allow your drawing to be accommodated on the paper, but being careful that the drawing should not be too tiny again. Now we do not have scales for angles. You must never do that. Angles remain as they are provided. The next item we look at are the angles of elevation and those of depression. Now consider this figure here. We have the ground surface PO, that is the level ground, and then we have a vertical wall RO. Now we have a point P on the ground. If an observer at P looks up at R, an angle X is created, and this angle is called the angle of elevation. Again, if an observer at R looks down at P, an angle Y is created, and Y is called the angle of depression. Please notice the position of those angles, particularly the angle Y. It is not formed on the wall, it is formed on an imaginary line QR. Now the wall is perpendicular to the ground, which means angle POR is 90 degrees. QR, I've said, is an imaginary line that is parallel to the ground PO. QR is parallel to PO, and QR is an imaginary line. Going back to the alternate angle properties, angle X and Y are alternate angles, and thus they are equal. So in other words, the angle of elevation is equal to that of depression. Next is compass and bearing, and a compass is an instrument used for finding direction. A compass has a suspended magnetic needle that always points to the north. There are 4 cardinal points, that is north, south, east and west. The angle between north and east, north and west, south and east and south and west is always 90 degrees. Pretty obvious. There are 4 secondary points, that is northeast, northwest, southeast and southwest. We shall not dwell on this stuff because you already are familiar with them, so we move straight to bearing. Bearing, simply said, is an expression of the position of a point in relation to another. For example, we can say that a point B is on a bearing of 40 degrees from A to the west of the North Pole. Now this means at position A, you have the North Pole and then a deflection to the left, because west is on the left. You deflect 40 degrees and that is the bearing of point B. So that can be represented as shown there. This means a deviation or a deflection of 40 degrees from the north towards the west. Now here we say the bearing of B from A is 40 degrees west of north, or north 40 degrees west. North 40 degrees west. This is called compass bearing and the angle is always acute. The angle can be east or west of either south or north, so that we can have angles such as north 20 degrees east, south 40 degrees west, south 45 degrees east, and so on and so on. But this is not very common, and we have another kind of bearing called the true bearing. In true bearing, all the points are given their angular distances measured only from the north in the clockwise direction. All points are measured clockwise only from the North Pole. The bearing must have a 3-digit figure measured only in the clockwise direction. There is no north, east, west or south, it is just the figures, and you have to bear in your mind that that angle is measured only from the North Pole and in the clockwise direction. So on the first figure we have B there. It is a deflection of 30 degrees from the North Pole, and the true bearing for that is 30 degrees, 3-digit figure. Again on the second diagram there, from the north going clockwise, you will measure 320 degrees, so the true bearing is 320 degrees. On the third figure there, you have a deflection of 160 degrees clockwise from the north, so the bearing is 160 degrees. So we look at location of points. Now with bearing, one can only know the direction, but to clearly define a point, the distance must be given. For example, one can say that B is 500 kilometers on a bearing of 0.99 degrees from A. Now with that kind of information, we can specifically get to B. What we do at A, we get an angle or a deflection of 0.99 degrees, and then along that line we move 500 kilometers and we will get to B. So unless the distance is stated, the point B will lie anywhere along the line of 0.99 degrees. Let me take an example here. 3 ships P, Q and R are sailing in the sea. Ship Q is 18 kilometers on a bearing of 0.60 degrees from P. Ship R is 6 kilometers on a bearing of 150 degrees from Q. Now I want to sketch the position of the 3 ships. Now to make it easy, I would have a compass at each possible point. The first thing I'll do is that I'll have a compass at P to allow me to locate Q, and then at Q I'll have another compass to help me locate R. Now at P, I'll draw the North Pole. Now I want to locate Q, and the information I have is that Q is on a bearing of 060 degrees from P. So I get an angle of 60 and then draw that line. Now Q lies anywhere along that line, but I have information that it is 18 kilometers from P. So along that line of 060 degrees, I measure 18 kilometers. Of course, I'll be using a scale, and I can find Q. So at Q, I need to have another compass, the North Pole. But now you have to be careful because the North Pole at Q must be parallel to that at P. So how I get that? I use the knowledge of alternate angle properties. So I know I need an alternate angle to 60 degrees. So I'm going to place a protractor at point Q and measure 60 degrees. So when I have that, the 60 degrees will be my South Pole. So when I have that, I will have my North Pole there. That's my compass. So that angle is 60 degrees because it is alternate to the angle at P. So I have my Q. Now at Q, I can locate R because from the information that I have is that R is on a bearing of 150 degrees. So I put a protractor at Q and measure 150 degrees from the North Pole. So I have that line and R lies on that line where the information tells me 6 kilometers from Q. So along that line, I measure 6 kilometers using my scale, of course. So I will have R here, and those are the position of my 3 ships. It is as easy as that. Next example, a town A is 80 kilometers on a bearing of 285 degrees from B. Another town C is 40 kilometers on a bearing of 025 degrees from B. Now I want to find the distance on a straight line between A and C and the bearing of A from C. Now it is always good practice to first make a sketch of the information. Note that the distances are different and your sketch must reflect this. You must also be familiar with angles to give you a good estimate of the image. Now from the information that I have, B will be my reference point. Why? Because from B I can be able to locate A and C, both of them. So the first thing I do is construct the North Pole at B. I have it there. And then I want to first locate point A. Point A is on a bearing of 285. So from the North Pole, I measure an angle of 285. Now that can be quite difficult because your protractor will only measure an angle up to 180. But you can reason this way. If from the north turning clockwise, we will have to go 285. And a complete turn is 360 degrees. It means if I move in the anti-clockwise direction, I will find the same line after deflecting 75 degrees. Why? Because 360 minus 285 is 75 degrees. So I can measure 75 degrees on the west side of the North Pole, and then I have that line. So A lies on that line. But I know the distance is 80 kilometers. 80 kilometers. So I'll measure 80 kilometers, of course using my scale, and I will have my A at this point. Again from B, I need to locate the position of C. C is 0.25 degrees from B. So at B again, I measure 25 degrees. That is very easy. So C is along this line, but I know the distance again, and it is 40 kilometers. 40 kilometers from B. So C is at this point. Now, you see there is enough information to allow you to get an accurate drawing. Just make sure you choose a good scale and be accurate in your drawing. To get the distance AC, you just have to measure it and convert using your scale. To get the bearing of A from C, you draw an accurate north pole at C and measure the angle between north and the AC line. Now, how do you do that? We need to construct a north pole at C. We need to construct a north-south pole at C. So remember, the north pole must be parallel to that at B. How do I get that? I have an angle of 25 degrees and I need to construct an alternate angle to that is 25 degrees at C. So I'll take a protractor and position it at C, lying along that line BC. Now at C, I'll measure an angle of 25 on the southern side, and then I will mark it. Let's say it is at that point. So when you join this point to the C, when you join this point to the position C, what you will create is a line that is parallel to that at B, and that will be your north pole. So from that, you can measure the angle from the north pole to the line AC, and you will have your angle there, and you'll be able to say you have the bearing of point A from C. Now the next important item is surveying. Land surveying simply means taking field measurements of the area so as to enable one draw a map of that land to scale. There are several methods of surveying, but we are not going to look at them all. We shall focus on the common area in examinations: how to enter information on a surveyor's book and translating such information so as to get the map that is described and find the area of that land. So let's start by translating surveyor's information into a map. Now in a surveyor's book, you will expect to find such kind of information as on your screen. The baseline is PU, which is equal to 100 meters, but be careful, do not try to add those values. Now the key things to note is that 1, we make move from the bottom upwards. We move from P to U always, and the distances along the baseline are measured from P. So let's describe this information so that you understand why PU is 100 meters. From P, we move 15 meters, and Q is 16 meters to the right from this point. From P, you move 15 meters, you will find a branch to Q on the right, and you move 16 meters, you will find point Q. Again from P, note it is not from the junction to Q. You move from P, you move 30 meters, and you will find a branch to R. R is 46 meters from this point on the left. From P again, you move 50 meters. S is 26 meters to the right from this point. Finally, from P, you move 60 meters. T is 26 meters on the left from this point. It's easy because to get the distance from the junction of Q and R, you just subtract 30 minus 15. Now we will have our sketch as follows. Let's see our sketch. The first thing that I'm going to do is draw the baseline PU. Now I will move from P 15 meters. There I will have my first junction to the right. To find Q, I'll move 16 meters from that point, and then I'll find my Q there. Now it tells me from P to the junction to R is 30 meters. So from that junction of Q to get to the junction of R, it means I will move 15 meters, so that it makes 15 plus 15 is 30. So the junction to R is here, and then to find R, I move 46 meters to the left. I have 46 meters to the left. Again, it tells me from P to the junction of S is 50 meters. Now so far I had moved 30. So from this junction of R, it means I move further 20 meters. So I'll have my junction to S, and to find the specific position of S, I move 26 meters to the right. So I'll have my S. Again, it tells me from P to the junction of T is 60 meters. So from the junction of S, it means I move further 10 meters. Why? Because I had moved 50. So this is the junction to T, and T is 26 meters to the left. So T is there. Now I was told that the baseline PU is 100 meters. So far I have moved 60 meters. 15 plus 15 plus 20 plus 10 is 60. So I'm remaining with 40. So from the junction leading me to T upwards to U, it means I'm remaining with 40 meters. So that's my distance. Now those are my positions. So to get the shape of the land, I will simply join them. There I have my piece of land. Now the baseline distance was only given to enable you to get the last distance, that is from the branch T up to U. The shapes formed are usually rectangles, triangles, and trapezia, and from their formula you can simply find the area of the land. Now in most cases the area will be required in hectares, so just remember 10,000 meters squared is equivalent to 1 hectare. 10,000 meters squared is equivalent to 1 hectare. So the next thing we are going to do, let's now try and enter the information in a surveyor's book if we are given the map. So we have the map of the land is shown on your screen, and I want to enter the information in a surveyor's book. So the first thing I'll have is my baseline. I'll start at point A. Now the first point is easy because I'll move from A. Remember, we always move from A. The distances indicated on the surveyor's book is the distance from A. So to begin with, I move 15 meters. I move 15 meters from A to the junction leading me to B, and B is 20 meters from there. So I will have at 15 meters, I'll have 20B, 20 to B on the right. Now from that junction to the junction at C is 5 meters further. So added that to 15 that I had moved, because I'm moving from A, I'll have 15 plus 5, that is 20. So I will have 20, and then on the left I have C10. Again, I have another 5 meters to move before I find the junction to D. So measured from A, I'll have 15 plus 5 plus 5, that makes it 25. So I will have 25, and then on the right I have 15 to D. Moving on, I have another 5 meters to move before I find the junction to E. So adding that, from A we have 15 plus 5 plus 5 plus 5 gives me 30. The junction is to the left, so I'll have E25. I then move another 10 meters to find the junction to F. So measured from A, so far we had walked 30 plus 10 is 40. So we have 40 and then to the left we have 25F, 25 to F. Another 5 meters from that junction to F before we find the junction to G. So that makes it plus 40. We have 45, and then we have G15 on the left. So finally, the 15 meters will not be indicated because we now move to H. We don't have any other junction. So the last value does not appear on the surveyor's book, but we know from the branch of G to H it's a distance of 15 meters, and thus the baseline AH has a total length of 60. We had already moved 45, and we can see from the map 15 further meters is remaining to get to H. So whenever asked to draw the map, you use a scale of appropriate size. Always draw a sketch first, but be reasonable when giving measurements. Draw a neat and accurate diagram, and tidy work attracts penalties in examinations. Now practice these questions to improve your speed. They are very common in examinations. Let us see the interior angles of a polygon, and let us consider a hexagon that is a 6-sided polygon. Now the marked angles are the interior angles. They are located in the interior of that hexagon. Now we want to find the sum of these angles. There are two ways we can use to find the sum of the interior angles of a polygon. And the first one, we shall divide this hexagon into triangles from one of the vertices. So we have this figure here. Now from this figure there are 4 triangles. Now the interior angles are now marked. Each triangle has a sum total of 180 degrees. So if we have 4 triangles, we have a total of 4 times 180 is equal to 720 degrees. So the sum total of the interior angles of a hexagon is 720 degrees. As simple as that. Now the second method, if we have that hexagon again, we may create triangles, but this time we make triangles from the center, and we shall have a figure of this nature. Now in this case we have 6 triangles, each of which has a sum total of 180 degrees. So in total we have 180 times 6 giving us 1080 degrees. However, remember the angles at the center were not part of the hexagon, and so we subtract them. They are angles at a point and they add up to 360 degrees. So we subtract 1080 minus 360, which gives us 720 degrees. Now you can use any of these methods to find the sum total of the interior angles of any polygon. Now let's look at something out of nowhere and divide this sum by 90 degrees. We have found 720 to be the total sum of the interior angles of a hexagon. So if we divide 720 by 90, we get 8. In general, if a polygon has n sides, there are 2n minus 4 right angles. 2n minus 4 right angles. Knowing that a right angle is 90 degrees, then the formula for finding the sum of the interior angles of a polygon is given by 2n minus 4, everything multiplied by 90, where n is the number of sides of that polygon. For example, if we have an octagon with 8 sides, the total sum of the interior angles is 2 times 8 minus 4, everything multiplied by 90, and we get 1080. For 20 sides, we have 2 times 20 minus 4, everything multiplied by 90 to give us 3240 degrees.
If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences. I think math teachers have a lot of responsibility for that. We haven't taught it so well. We haven't provided the resources that people need. And so I think if you need help, you need to get it, and you need to get it early. And you need to work at it.